Today, we are going to talk about Dijkstra's algorithm and how it works. Imagine you have a map of cities called nodes connected by roads called edges. Our task is to find the shortest distance from one city, let's call it City A, to all the other cities like City B, City C, and so on. To get started, we'll use a table to keep track of two things for each node. First, the shortest distance we know from node A. Second, the previous node on the shortest path to that node. At the beginning, we don't know the distances, so we set them all to infinity, which means unknown. The only exception is node A itself, which has a distance of 0. We also have two lists, one for the visited nodes and another for the unvisited nodes. At first, all the nodes are unvisited. We start with node A and look at its neighbors, which are node B and node C. The distance from A to C is 2. We add this to our table and mark A as the previous node for C. The distance from A to B is 4. We add this to the table too, with A as the previous node for B. Now that we have checked all the neighbors of A, we can mark node A as visited. Next, we look for the unvisited node with the shortest distance. This is node C with a distance of 2. Now, we check all the neighbors of node C, which are node B, node D, and node E. First, we check the distance from A to B through C. This distance is 3. That's 2 from A to C plus 1 from C to B. Since 3 is shorter than the distance of 4 we had before, we update the table and set C as the previous node for B. The distance from A to D through C is 7. That's 2 from A to C plus 5 from C to D. We add this to the table and set C as the previous node for D. The distance to E through C is 8. We add this to the table and set C as the previous node for E. Now that we have checked all the neighbors of C, we can mark node C as visited. Next, we move to node B because it has the shortest distance among the unvisited nodes, which is 3. We check the neighbors of B, including node D. The distance from A to D through B is 6. That's 3 from A to B plus 3 from B to D. Since 6 is shorter than 7, we update the table and set B as the previous node for D. Now, we can mark node B as visited. Next, we move to node D. Its neighbors are node E and node F. The distance to E through D is 8. That's 6 from A to D plus 2 from D to E. Since this is the same distance we already have for E, we don't need to update the table. The distance to F through D is 10. We add this to the table and set D as the previous node for F. Now we can mark node D as visited. Next, we visit node E. The only neighbor left to check is node F. The distance from A to F through E is 11. That's 8 from A to E plus 3 from E to F. But since the distance of 10 we found earlier is shorter, we don't update the table. Now we can mark node E as visited. Finally, we visit node F. Since it's the last node, we are finished. All the nodes have been visited, and our table now shows the shortest distance from node A to every other node. And that's it. Now you know how Dijkstra's algorithm works to find the shortest path in a graph. Thanks for watching. If you found this helpful, please like and subscribe for more videos like this. See you next time.